All right, so here we have a total of $18,000 is invested. Part of it at 6% and part at 9%. The total interest after 1 year is $1,248. How much was invested at each rate? So we have to kind of label some items. So let's say X, because X is a good variable, is equal to maybe the amount invested at the first one, 6%. All right. So if they invested X at 6%, how much did they invest at 9%? Well, that's going to be 18,000 minus X because we're taking off how much they invested here, and whatever's left is going to be what's invested at the 9%. Okay. Now, what do we remember about interest? Well, interest is equal to PRT. Now, this one really tells us only one thing. It's 1 year. So T is 1. So that's pretty nice one because we don't have to multiply by 5 or 10 or whatever. But in any case, what do we need to do? Well, we need to maybe set up a table. Let's set up a P and an R, and then we'll have T was 1, so we really don't have to do that. And then we can have an I. So P is going to be how much they invested. Well, they invested X, and they invested 18,000 minus X. Now, what was the rate? Now, remember, when we do rates, we have to convert both of those to decimals. So that's going to be 0.06 and 0.09. So that'll be 0.06, 0.09. Time was 1, so we don't have to worry about that one. Now we just multiply. P times R times T is equal to I. So that's just going to be 0.06x. All right. So now this one's going to be 18,000 minus x times 0.09 times 1. Well, 18,000 times 9 is going to be 0.0072, and it's going to be 16. Move it 2 decimals, so 1620. And then time minus 0.09x. Okay, so that's the two interest amounts after 1 year invested at that much on each one. So now what do we know? Well, now we know that together they should add up to that. So let's add those two together. 0.06x and then plus 1620 minus 0.09x equals 1248. Okay. Well, now we have what? We have like terms. So we can add that to that. And let's get rid of this one because we don't want it on this side. All right, so 0.06 minus 0.09 is minus 0.03x. And if we take this one and subtract it, let's take it higher over lower. Let's take 1620 and then 1248, subtract. And so that's going to be a 5. That'll be 11. That's going to be a 2. That's going to be a 7. That's going to be a 3. So that's going to be equal to negative 372. Now we have to divide by negative 0.03. And so X is equal to, and this is going to be how much was invested at 6%. So let's take 372 divided by 0.03. And we get $12,400. Okay, so that's how much that one is. Now we want, after that, we would need to take that from the 18,000, and that's 5,600. All right, so 12,400 for this one. At 6%, and 18,000 minus x is going to be 5,600 at the 9%. Okay. Now, one thing we can always do is we can always check our work, and that's what we should have been doing all along here, but we didn't. So, but let's do it on this one. Let's see first to see if it works, and go from there. So, does 12,400 plus 5,600 equal 18,000? Well, if we add that, that's 0.00018. Yep, that's 18,000. So now let's see if it equals the amount of money we earned. So what we're going to do is we're going to take the 12,400 times 0.06 plus, and then we had the 5,600 times 0.09. Now we're supposed to get 1248. We get 1248, and so it does check out. Okay, so those then are the correct answers for this problem. Okay. All right, what about this one? So we have an investment portfolio earned $2,000 in interest last year. If 3,000 was invested at a certain rate of return and 24,000 invested at a rate that was 4% lower, find the two rates of interest. All right, so this time, instead of knowing amounts, we have to look at interest rates. So let's let X, again, just because X is a good term to use, let's let that be maybe the first rate. And then what's the other one? Well, it's going to be 4% lower than the first one. So X minus, now let's go ahead and convert it to decimal, because when we're doing these, we have to have it in decimal. So we're going to subtract off 4%, and that's going to be our second rate. So this again is 0.04. So instead of plugging in X minus 4, which is going to give us the wrong answer because we have to put everything into equations in a decimal form, we're going to go ahead and put it into decimal form here. All right. So investment earned last year. So last year, that means T is equal to 1 again. Okay. So we're going to have I equals PRT. So let's do all of our items again. P, R, T, and then our I. Okay. So our P, principal earned 3,000 was invested first, so that's going to be that interest, our amount, and it was at a rate of X, and we had a T of 1. Well, that's going to give us 3,000X. Okay. Now this one said we invested 24,000, and it was X minus 0.04, and again 1. So we have 24,000 times X, so that's 24,000X minus, and now we have 24,000 times 4, that's 0, 0, 0, 16, that's 8, 9, move it 2 decimals, 960. Okay. And so now we have to say, okay, well, the total earned is 2010. So we're going to add this interest to this interest equals that total. So 3,000x plus 24,000x minus 960 equals 2010. Well, here we have a like term, here we have a like term, and we can get that like term over there if we add 960 to both sides. All right, so that's gone. So 24,000 plus 3,000 is 27,000x, and this is going to equal, and now that's going to be a 0, that's going to be a 7, that's going to be a 9, that's going to be a 2, and so now we divide by 27,000, and so that's another good use for a calculator. So let's do that. So we had 2970 divided by 27,000, and we get 11% interest for that one. And we can go ahead and subtract off that 0.04 to get the second one. So we have 11 and 7, but we should have known that already. So X was equal to 0.11 or 11%. And X minus 0.04 was equal to 0.07 or 7%. Okay. Now, this isn't one where we can just add those two together and see if it works. What we have to do is we have to plug it back in and see if it actually fits our model. So now we're going to take the 3,000 times 11%. So we have 3,000 times 0.11 plus we had the other one was 24,000 times 0.07, and we should get 2010, and we do. And so that means those two are our correct interest rates for this problem. Okay. All right, so let's pause there and we'll come back for more.